Hi, and welcome to this tutorial of how to build a sequence of teleport destinations in Unreal Engine 5. So in the VR template, you can teleport wherever you want to in the space, and you create some navigation on the ground, and the player can choose where it is they want to go. Sometimes that's not what you want for your experience. Maybe you are doing a previs of an architectural build or something, and you really want to be able to give a guided tour through specific places, and you don't want your client to get lost in a closet or something, and having some challenge of communication between the two of you. So what we can do is we can disable the autonomous teleport decisions, and we can set a bunch of stations where the player would go to in order, and they can go forwards or backwards in that order. So the way we're going to define where those places are is we're going to create a few blueprints that have arrows on them that show which way you'll be facing and where you'll be. So we'll place one here, we'll place another one over there, we'll place them around, and then we will build an array at runtime where Unreal will check how many of these positions there are and load up all their transform data, so that when the button is pushed on your controller, you'll go to the next one. So by the end of this video, you'll be able to modify the VR template quest controls, create new input actions, create related events that occur when you push buttons, and have a custom built array that we will be sorting by display name and assigning the transform of one of these placeholders to the player's pawn. We're going to assume that you've got general knowledge of Unreal Engine, of blueprints, that you can set up your own VR headset, because we're not going to get into troubleshooting any of that, and that you are familiar with the enhanced input action system, because we're going to touch on it and how to add functionality to it, but we're not going to get into any depth of how it works. Some additional understanding of math in blueprints is helpful, but I will be taking you step by step. Anyways, thank you so much for joining, and let's get into the project. First step is going to be a bit brief. We're going to create a VR template project and then build some blueprints that have an arrow showing the direction that we want the player to be pointing, but not to render in the game. So let's get started here. We will launch the engine, and let's go into the games template. Here we have virtual reality, so make sure your project is going where you want it to. And I'm going to call this tutorial 6 and create. Okay, so now that we're inside our project, I've created a folder called tutorial content, and let's create a blueprint actor, call it BP teleport location, and let's open that up. So we want to know which way this actor is facing so that we can apply the rotation that we want to our character when they teleport. So we just simply add a arrow component here, and by default it faces forward, so we're in good shape here. And let's see if we can add the render visibility, actor hidden in game. Can we add the tag here? We can add the tag, and we'll call this teleport location. So now every one of these that we place in the world will have the same tag, and won't show up when we play the game, which is exactly what we want, because this is a functional tool to help us in the navigation of our game. So let's now take a BP teleport location, bring it out into the world. So to start with, maybe we'll place our guy to the back. This will be teleport position 1, and then we will have, I'm going to alt drag now, position 2 will be turned around and looking back the way we came, but from this position maybe. And let's create another one. Where should we put him? Let's add a third one here. Again, looking back into the world. So 3 is enough for us to understand that this is working, and we can see the tags are still applied across all of them, and the visibility, actor hidden in game, is checked for all 3. So we are now in good shape to have this all set up. And I think there is a player start here in the world. Yes, there is a player start, but we're going to override that at the beginning of the game and place the character at the first dummy location. And just to be sure that the regular teleport functionality of the player being able to jump around the world is deactivated, let's just be sure that in the world there is none of this navigation built in. So if you're familiar with the VR template, you know that this is created by adding nav volumes, and if you hit the letter P, it toggles on and off. So let's just find everything called nav. I've got the bounds volume, no teleport, and a recast nav mesh. I'm just going to delete all 3 of these, and now when I press P in the world, nothing happens. So when we start the game, the normal teleport functionality will not work. And now that we've set up our template level and we've placed our dummy locations of where we want our player to jump to in the world, let's look at building the array. Now that we've got our VR template going and we've placed some BP teleport location actors in the space, so we have the sequence of locations that we want the player to be able to step through in the world, we need to create an array at runtime so we can keep the transform information in order so that we can go from one to the next to the next. We're going to do this by building an array that stores the transforms in the order that we want to go. So one of the challenges that we're going to face is when you build an array, it runs by the ID name. Which is over here, which doesn't necessarily correspond to the order of the blueprints in your world. So let's say between place 2 and place 3, we wanted to have another position. But if I duplicate location 2 and rename this one to 4 and this new one to 3, it sorts them here by the label, which does not reflect the order of the ID name. So if we built an array at the moment, it would do location 1. Let's just relabel that now so it's a bit more consistent. Location 1, then it would do location 2, and then following the ID name, it would go to location 4 and then location 3, which for clarity, let's just move it around here. Okay, so this runs a little counter to what you may want for organizing, but it is a feature of how the arrays are built. So we're going to put in a sort function that deals with this. So first up, let's create a new player controller, blueprint player controller, and let's call this BP player controller teleport locations, and we'll set this as the player controller for our world. Now let's go into this and into the construction script. So first up, I know we're going to build 2 variables. The first one we'll call teleport locations, and this is going to be a series of transforms, and it will be an array. And then we're going to build actors by name, and this is going to be a set of strings because it's display names. Okay, so we're going to be doing a few things, so let's put a sequence node. And first up, let's get all actors with tag. And our tag is going to copy it because we don't want a mistake. Right, I was looking in the world settings there. Right, clear that out and clear that out. Okay, and go back into our BP. So the tag is teleport locations, and we will for each loop, each of these guys, we're going to get the display name. And we want to add to an array, which is this one. Okay, now with that done, then we're going to do a for each loop. And we'll print all the names. So let's compile and save this. And if we hit play, teleport location 1, 2, 4, 3. So as we saw, these are not sorted, but we have them all, which is perfect. So now we can add a pin, and we'll bring in actors by name, and we will sort string array. And we will run it to print it all again. And let's save that. Let's hit play. 1, 2, 4, 3, 1, 2, 3, 4. That was a bit quick. I'll pause it on the screen. So that is quickly sorting the array for us, which is exactly what we want. So let's go back into here and we'll comment this out so we're not getting lost. We have create array of names, and we have sort array. Now what we want to do is add to the target locations in this corrected order. So we'll copy the get all actors with tag, and we want to again do a for each, but we want to do a for each for the actors by name. So let's for each loop. So for each one of these, we want to find its name match in our list of actors with the tag. So we'll take this out and put for each, and we'll loop body for this, and we want to get the display name. Okay. And now we want this array element to equal exactly string. Great. So if these two match, we want to do a branch. And we're going to add to an array. That's not the way to do it. Let's bring this out here and add. Okay. We want to get the get actor transform, and we're going to add it in if this is true. Great. So again, we're getting all of the actors, and we're saying, okay, for each of the actors in the actors by name array, I want you to see if it matches each of the actors that have that tag. So if the name matches, add the transform to the teleport location. If it doesn't, carry on with your for each loop and keep going till we find the one that is true, add its transform to the teleport locations. Then it'll go to the next one of the names and find the match and populate it. So if this has worked properly, we should now be able to take the teleport locations And for each, we'll print the element. So this should print out a set of 5, 4 teleport locations. 1, 2, 3, 4. Okay, so to be sure that they're in the right order, let's have this do a duration of 20 seconds. So compile, save, and if we hit play, okay, so teleport location 1 is -440, -30, -440, -30. The next one is 1010, 340, 1010, 340. Next one is 1020, -280. The last one is 190, -420. So it has sorted them in the order of the names and not in the order of the ID names, which is exactly what we're looking for. So now you could have as large a world as you want. You can create the item labels. If you do want to insert one, doesn't mean you can have to do a little bit of relabeling, but at least it's going to be clear to you what that sequence is. And it's not defaulting to the ID name, which would now have you copying transforms from object to object and like doing a rolling update, which would be quite painful. Here you just have to update the name and then adjust all the names, and you'd be in good shape. So that is building the array and testing it out. And we are now going to move on to the third part, where we build the input actions and the events that actually move the player from place to place in the next part. Okay, so now that we've created our VR template map, we've added blueprints that have arrows in them so we know which way they're facing. We place them around the level to create a sequence of places we want the player to be teleported to. And we built an array that puts those blueprints into a grouping that we can access. We now want to create the input actions that tell the Quest controller when you press one button to go to the next location, when you push another button to go to the previous location, and apply that to the player's position. So to begin with, in tutorial content here, we're going to create a couple of input actions. I'll call it input action next location and input action previous location. And we'll open it up. And I'm really just adding the trigger to be pressed. Now, for these to be accessible to the player's controller, they need to be put into an input mapping context. So instead of creating a new one, I'm just going to go into the VR template, go into the input menu, find IMC hands, and we're going to add the mappings. So we've got next button, no, next location, and we've got previous location. Now we need to associate these to the Oculus Touch right A press, and to go to the previous location we'll go with the B press. There it is. And both of these we want to make sure the trigger is associated to pressed, just that we don't have any funny business. And that is all the setup we need to do with that, because when we go into the player pawn, which is here in the blueprints, there, we can see that the enhanced input local player subsystem has the default mapping context added, and then it's got the mapping context of the hands added. And I've already upped this to 10 just to be sure it gets taken as a higher priority than anything else, and it's got the hands in there, and so we are in good shape. So what we want to do now is we need to be able to access the player controller's teleport location array. So let's come here to the sequence this is the event begin play sequence. I'm going to add here, and I want to get the player controller, and we're going to cast to the player controller, BP player controller. That's the one. And in here, we are actually going to save this as a variable. Great. So this here is a sequence number 2. And let's put a comment here, and this would be set player controller variable. Great. So on our first input action, which is the next location, we want to just be sure that this is working, and let's print a string that says next, and let's get the previous one. There we go. Nope. Selected the wrong thing there. Previous location. Action events. That's the one. And we will have a print string that says previous. So let's compile that, come over into our VR template and try out the VR. I'm not actually going to put it on because I've got glasses. It's a bit uncomfortable, but I can just hold it and see that it's working. And I have the controller here, so if I press the A button, it says next. If I hit the previous button, it says previous. Wonderful. Okay, so going back into the VR pawn, let's just save. Everyone loves to save. In the VR pawn, what we're going to do now is we want, as the BP player controller, we want to get the array, what was it called again? Teleport locations. And we want to get a reference. So it's going to be referencing index 0 at the moment, but I want to control that. So let's add a variable here called teleport index, and this is a integer. And let's compile that. Let's bring it in. Okay, so that is set to 0. So we're all happy with this. And then what it's going to do is it's going to be applying that to the player pawn. So let's get the player pawn, and we are going to teleport the player pawn to the location and rotation of the current teleport index. So let's plonk that location into there, the rotation into there. Let's make it official here. So that's happening. And just as a test now, let's take the teleport index and let's increment it so we can see if it's actually functioning and sending us to the next place. So if we hit play, okay, so let's hit A. So it's done something, but it's not doing it correctly. So, all right, all kinds of errors here. So I think it's because I had a BP player controller in from earlier, because I just tested it out before tutorial. So let's now use the correct one, and let's come here and hit play. Yeah, so this is cycling us through. Great. So the errors here are fine because we're going above and beyond the number of indexes there are. So, okay, this is all looking good. Then we want to go backwards. So let's copy all this stuff here. And we'll start by taking the teleport index and subtracting 1. and that will be the index. No, that will be the index that goes into there. And then we need to do the teleport. I'll just push this down so it's not blocking that. All right, and this player pawn should be, there we go. This location goes into there, this rotation goes into there. Let's compile, and let's see if this works. So hitting the A button takes us forwards in the correct pattern, and if I hit the B button, it is taking us backwards. That's fine. Great. So the reason why there was a little stutter, I had to hit the increase twice, or hit the previous button twice, is because this isn't in the best place. Let's move this teleport increase change to the beginning. So you press the button, it increases the index, and it moves you forward. That's all looking good. Now I want us to start at the first teleport location. So up here, when we set the player controller variable, I also want to get the teleport locations and get a reference. I want to start with 0, and I want to get the player controller, get the player pawn, and teleport him. So this will start us off at the first position. So if I split the struct pin, put this location to there, put that rotation to there, carry on through. Okay, so now when we start, the input actions are going to be allocated here with the mapping context. Then we're going to buffer the player controller identity here and set it as a variable. But here in the moment, we're going to then take index 0, which is the very first of our transform locations, and it's going to teleport the character there. So that's where we start with the game. And then when you press the button, it's going to increase that index from 0 ++ to 1 and take that index. You know what? Let's just be a little tidier here, and we'll just bring that up. So make sure that it's taking the correctly updated index. Teleports the character to that place. In fact, I'm just going to make this a bit more legible by pulling that down there. Great. And when we push the back button, the previous button, it's going to decrease the index by 1 and use that index number and teleport the character there. So let's compile and let's test this out now. Okay, so A button. Okay, we're already in the first position, which is great. A button takes us number 2. This is number 3. This is number 4. There's nothing beyond. So rather than generating an error, let's just hit B and go back. So here's the previous and the start point, and there's nothing below that. So what we need to do is create a wraparound for the index so that if we go beyond the number of entries in our array, it's going to wrap it back. If you're going positive, we'll get to 4 and that'll become 0. Or if you're going below 0, it won't go to -1, it'll go up to position 3. So let's use the modulus for that. Now, what we are going to need to do here is set the length. So let's take the teleport locations here and let's get the length. Let's just tidy this up. And we'll store this length in a variable. So I'm just going to promote to variable, and we'll call this teleport length. And we need this to be connected. Great, so we've got that stored. So what we're going to need to do here is when we increase the index, we want to check if it's gone too high. So we'll use a modulus with an integer. you feed the current index into the top of the modulus, and we want to put the length into the bottom. What it's going to do here is divide the number by its length and give us the remainder as the result, because the remainder is where we sit currently in the index. So if we had a group of 3 and you had a 5, divide 5 by 3, you have one whole set of 3, so we deduct that. Remainder 2, it would put you in position 2. So we'll take that result, and that is the index. So let's compile and check that this works as I'm saying. So if we press A, there's position 2, position 3, position 4, position 1, position 2, position 3, position 4, position 1. So that is working perfectly. We need to now do it for the previous location. Now this operates slightly differently. We're going to take the modulus, but first we need to add this number to the teleport length, and that goes into the top part of the modulus. Teleport length again goes into the bottom part, and then this feeds in to the index of the teleport location array. And let's compile and let's do a quick test here. Okay, so A takes us to the next one, B takes us to the previous one, and there we are from position 1 to position 4. So this is working just as expected. So that brings us to the end of our tutorial. Everything's worked out exactly as we were hoping. We've got a series of teleport locations, and we've disabled the autonomous teleports of the user, so they can't go wherever they want. They can only go in the sequence that we want, forwards and backwards. So thank you very much for listening. Please let me know if you have any comments or suggestions on improvement for next time. And thank you very much. Have a great day.